All right, now recording. Okay, let's set up the shared screen. We're almost done, folks, as you probably know. In fact, everything that we need to cover, I will at least introduce by today. So we only have 2 sections left, 12.3 and 13.2. I'm going to do some of each. Okay, so again, rather than doing 12.3 today, 13.2 on Tuesday, then that only gives you 2 days to learn 13.2. I thought I'd do some of 12.3, an incomplete job, and an incomplete job on 13.2, but enough that I think you can get going on both of them. So that way for 13.2, rather than having just 2 days before the test, you have a whole week before the test. And then I'll pick up the loose ends Tuesday, and then we'll have our next test next Thursday. Okay, so remaining calendar. So we are here. So 12.3 and 13.2 today, and then I'll give you a quiz at the end. And Tuesday, same thing, 12.3, 13.2. And then if you have any questions about the test, you can bring it up. Okay. And last regular test is on the 13th. Coverage is only these 4 sections, 12.1, 12.2, 12.3, 13.2. Okay, then 18th we review for the final, and then Tuesday the 20th we have the final, and then we're finished. Right, so that's actually just 2 weeks from today. 2 weeks from today, it's all over. Okay, so the final exam, just study the old exams. How about you can just have all the same cheat sheets as before. So the formula sheet you had for the first test and the second test and the third test and the fourth test and the fifth test, but we haven't had the fifth test yet, but just bring them all in. You don't have to redo them. No sense in reinventing the wheel, so to speak. If you already have them, just bring them in again. I hope you kept it. Now, if you threw it away or lost it, then you kind of have to reconstruct it. And by the way, you're allowed to add stuff to it. So maybe after you took one of these tests, right? And then you said, oh, I wish I put that in, you can do it now and put it in, sneak it into your paper so you have it for the final exam. Okay, so the best way to study for the final exam is just look back at the old exams. And I will pick, let's say, 3 questions from each test. 3 times 5 is 15, so maybe 15 questions total. I'll pick 3 questions from the first test and 3 from the second and 3 from the third and 3 from the fourth and 3 from the fifth. Now, I'm not promising you the very same questions, but questions similar for the final exam. Okay, and that'll do it. Okay, so let's see. Okay, yeah, anybody who joined late, put your name in the chat. So Jonathan, I see you. I'll get you later. I already put away the roll sheet, but we'll just go ahead with it. Okay, so any other general questions about what's happening? Okay, so I'll do some of 12.3, I'll do some of 13.2, and then after I think I've done enough, we'll take the quiz, and then next Tuesday, same thing. And then if you have any questions for review for the test, then bring it up on Tuesday, although I'll let you have a little bit of time Thursday in addition. Okay, and as usual, you turn this in for homework, right? You must turn in at least 70% of the homework. Okay. All right, so 12.3, go ahead and get started with it. It's very, very similar to last time, only with exponential and log functions. So 12.3, okay, and I'll go ahead and show you the problems in my book for those of you that don't have the book and aren't getting it, on page 804, 13.2, there's that, and that, and how high do we have to go up? Up to here. Okay. And let's see. I might as well give you 13.2 also while I'm at it. I can find it here. $13.2. Okay, 13.2, page 804. So as I mentioned last time, these integrals have numbers on the funny looking S. Okay, it basically means you're going to be plugging in those numbers. And I'll show you how to do that. It's not really that hard. It's more over there. Okay, so that'll do it. Okay, so my number 2 can temporarily ignore all the red lines that are. The original was 4e to the 4x dx that we're integrating. Okay, so do you see a function in its derivative? 4x has a derivative of 4. So let that be u. U equals 4x. Du equals 4x dx. That's the way you write it. Okay. Again, using the Leibniz notation, you would say du dx equals 4. Okay, but it's easier to just say du equals 4 dx. So next step, change this to u. 4 dx, they don't have to be together. Remember, you can pick up the 4 and move it over there. Multiplication is commutative. You can change the order. And that becomes du. So my integral becomes e to the u du. Very easy. So what's the integral of e to the u? E to the u plus c. And then just change u back to what it was. It was 4x. Final answer, e to the 4x plus c. Okay. Double check. What's the derivative of e to the 4x plus c? Well, you already know the derivative of any constant is 0. Derivative of e to the 4x is e to the 4x times the derivative of 4x, which is 4. 4 e to the 4x. That's exactly what we got. Okay. 4 integral of e to the 2x. I'll show you 2 ways of doing this. Okay. We could do the u substitution again, where you say, okay, I don't like 2x. I'd rather just have u, right? So we say, okay, I want that to be u. So let u be 2x. Du equals 2 dx. Okay, the derivative is 2. Put du here, dx there. Now, I don't have a 2, so I put in a 2 in red. So the red means it wasn't there originally. 2 inside, 1/2 outside. Therefore, the next step, e to 2x becomes e to the u. 2 times dx, 2 dx is du. Okay, so we're ready. Integral of e to the u is itself, because the derivative of e to the u is itself. So 1/2 e to the u plus c. Change u back to what it was. 1/2 e to 2x plus c. Okay. And there we go. Now the problem is actually finished, but I'm going to dig a little bit deeper to make things a little bit easier for you, and you might prefer this. First, let's double check. What's the derivative of this? The derivative of this would be the same thing, 1/2 e to the 2x times 2, which is the derivative of the exponent. Well, 2 times 1/2 is 1, so I get e to the 2x back. And of course, the derivative of any constant is 0. Okay, now that works. Okay, there's another way you can do it in this case, which is a lot faster, I think. I will let you go straight from here to here. If you remember that when you integrate, it's differentiation and reverse. Okay, and so what do you mean by that? Okay, suppose I ask for the derivative of e to the 2x. Chain root, right? It would be e to the 2x times 2. So what happened? I multiplied by 2. 2 e to the 2x. So therefore, if I go backwards, if I integrate, I do not multiply by 2. I instead divide by 2 or multiply by 1/2. So it makes sense, right? So since integration and differentiation are opposite operations, and then I say to myself, okay, if I differentiate by the chain rule, the derivative of e to the 2x is e to the 2x times 2. So therefore, when I integrate, it's e to the 2x divided by 2 or multiplied by 1/2, as you can see here. Okay. Same kind of game comes over here. 250, integral of 250 e to the negative 0.5x dx. Okay. Now, using a u substitution, you would say let u equals negative 0.5x. du equals negative 0.5 dx, which means I need to introduce in red a negative 0.5 inside and 1 over negative 0.5 outside, and the 250 can come outside also. Now, 250 times 1 over negative 0.5, you can punch it in your calculator if you want, negative 500. E to the that, e to the u, and then negative 0.5 dx is my du. All right, so integral of e to the u is itself negative 500 e to the u plus c. Then quickly change u back to what it was, negative 500 e to the negative 0.5x plus c. Okay, and that works. But again, an alternative from the get-go, you could just do the chain rule in reverse for this and say, okay, if I differentiate e to the negative 0.5x, I will do e to the negative 0.5x times negative 0.5. So therefore, I want to integrate, instead of times negative 0.5, I would divide negative 0.5. And that's exactly what happened at this step over here, as you can see. So you get the same answer. Okay, 10. The original was like this, x e to the 2x squared dx. Do you see a function and its derivative, sort of, right? I see 2x squared. What's the derivative of 2x squared? 4x. I don't have the 4, I have the x, but you know what to do. Put in a 4 and outside put a 1/4. Okay, again, what you normally look for is an exponent which is 1 higher than another. This is degree 2, this is degree 1, right? So that tells you, let that be u. The derivative is going to be something involving that. Okay, so u equals 2x squared. That way, the next step, it'll be e to the u. 2x squared. Du is 4x dx. There's my x. There's my dx. Again, don't worry about they're not together. You can pick it up and move it over. It needs a 4. So put a 4 inside and a 1/4 outside. Again, that way you're multiplying the expression by 1, which means you're not changing its value. Okay, so the next step, e to the 2x squared, substitute e to the u. 4x dx, 4x dx du. But I have a 1/4 outside. So I'm integrating 1/4 e to the u du. Okay, and of course the integral of e to the u is itself 1/4 e to the u plus c. Change u back to what it was. It was 2x squared. Final answer, 1/4 e to 2x squared plus c. Let's check. What is the derivative of this thing? Okay, well, the derivative of any constant, of course, is 0. The derivative of 1/4 e to 2x squared is 1/4 e to 2x squared times 4x. That 4 would knock out that 1/4. You'd have an x left in front. And there it is. It's perfect. It works. Okay. All right, 14. The original was x cubed over e to the 4x to the 4th dx. Do you see a function and its derivative almost, right? This is x to the 4th. This is x cubed. So you know the derivative of x to the 4th is going to involve an x cubed. So that tells me this should be my u. So let u be 4x to the 4th. Du is 16x cubed dx. I have x cubed dx. I need a 16. So 16 inside, 1/16 outside. All right, so I have 1/16. 16x cubed dx is my du. E to the 4x to the 4th is now e to the u. Okay, but I can't integrate it like that. I need the e to be upstairs. So we just write it as a negative exponent. So 1/16 e to the negative u du. Okay, now what's the derivative of e to the negative u? The negative e to negative u. You need a -1. So when you integrate, same thing. Instead of, I guess you could say, instead of multiplying by -1, you divide by -1, playing the same language as here. But if you divide by -1, it's the same thing as multiplying by -1. So -1/16 e to the negative u. And then just change u back to what it was, 4x to the fourth. So -1/16 e to the negative 4x to the fourth plus c. And again, an exception to the rule of having a negative exponent. It's always okay to have e with a negative exponent in your final answer. That's actually cleaner than 1 over e to the 4x to the fourth. So we are allowed to leave it like this. Okay, 16, it's almost like two integrals in one. Okay, integral of x e to the 3x squared minus 5 over e to the x over 3 dx. Okay, now I can do this separately. I can do this separately. So that's what I decided to do. So I break it up into two integrals. Okay, the integral of a difference is the difference of the integrals. So I call this I1, the first integral is, ignore the red, x e to 3x squared dx. I'm calling that I1. Minus integral of 5. Okay, I'm going to rewrite that as e to the negative 1/3 x dx. That's I2. Okay, it's in the denominator, so I bring it upstairs. Dividing by 3 is the same as multiplying by 1/3. Okay, so it's almost like I take a timeout, figure out I1, figure out I2, and then put them together. So the original integral I is now I1 minus I2. Okay, so let's work on I1. X e to the 3x squared, which would be my u. 3x squared, because its derivative is going to involve x, which I have here. So u equals 3x squared. Du equals 6x dx. I have x dx. I don't have a 6, so put in 6 inside, 1/6 outside. So I1, remember, I'm only working on I1 now. 1/6 e to the 3x squared is now e to the u. 6x dx is du. So the integral is 1/6 e to the u plus c1. Technically, you can't just put plus c here because this has a c, but this I2 is going to have its own c. So if you just put plus c, you're implying they have to be the same, but they don't. So I'm going to call this c1. I'm going to call this c2. But in the final answer, I'll be putting them together. And when you have c1 plus c2, then it'll just be a c. All right, so plug back in. 1/6 e to the 3x squared plus c. That's not a negative there. It's just a stream mark there. Sorry, that's 1/6 e to the 3x squared. That's not a negative sign. That's just a splotch in the paper. Just like that's a splotch in the paper, I guess. It's 1/6 e to the 3x squared, okay? Plus c1. I2, I am going to do that shortcut rather than a u substitution. Okay, so let's look at 5 e to the negative 1/3 x. I'm going to do the opposite of differentiation, taking a derivative. So if I ask for the derivative of 5 e to the negative 1/3 x, you would say 5 e to the negative 1/3 x, then by the chain root times negative 1/3. So when I integrate, instead of multiplying by negative 1/3, I divide by negative 1/3. That's a little bit faster. Okay, so 5 divided by negative 1/3 means 5 times negative 3, negative 15 e to the negative 1/3 x plus c2. Now I put them together. I got the answer I got for I1, subtract the answer I got for I2. Okay, so 1/6 e to the 3x squared plus c1 minus the thing I got for I2, which is negative 15 e to the negative 1/3 x plus c2. Okay, so 1/6 e to the 3x squared plus, minus and minus, 15 e to the negative 1/3 x plus c1 minus c2. But now I can just call that an arbitrary constant. C1 is any real number minus C2, which is any real number. You get any real number. So in your final answer, you can just finally put plus C. So 1/6 e to the 3x squared plus 15 e to negative 1/3 x plus c. Okay. All right, then let's see, moving on to 18. 8x to the 7th over x to the 8th minus 1 dx. This is perfect, right? What's the derivative of x to the 8th minus 1? 8x to the 7th. So u equals 8 x to the 8th minus 1. du is 8x to the 7th dx. So the top is du, the bottom is u, okay? So it's du over u. If you say, I don't recognize that, you can always sneak in a 1. So I have integral of du over u, put a 1 over u, right? And then 1 over u tells me, okay, that's my natural log, right? Strictly speaking, it's ln absolute value of u plus c. The derivative ln of absolute value of u is 1 over u. So the integral of 1 over u is ln absolute value of u plus c. Okay, then just put it back in. So ln absolute value of 8x to the 8th minus 1 plus c. Okay, so this section, we're doing exponentials and logs. We already did a bunch of exponential substitutions. Now we're doing log substitutions. Okay. Let's check. What's the derivative of this guy? We would go 1 over x to the 8th minus 1. So x to the 8th minus 1 is on the bottom, right? And then by the chain root times the derivative of the inside, 8x to the 7th. Perfect. And of course, the derivative of any constant is 0. So we're good. Okay, 20. Ignore any red. The original was y over y squared plus 1. Second degree, first degree. The derivative of second degree is probably going to be first degree. So let u be the bottom. U equals y squared plus 1. du equals 2y dy. I have y dy. That means I multiply by 2 inside, 1/2 outside. Okay. So I have 1/2 integral 2y dy is du divided by y squared plus 1 is u. So it looks once again like this. And a lot of problems at the end here are just like that. Du over u is 1 over u du. That's my natural log. So 1/2 natural log absolute value of u plus c. Change u back, y squared plus 1. So 1/2 ln absolute value of y squared plus 1 plus c. Okay. And this gets a little tricky. In this particular case, what happened from here to here? I dropped the bars. It should be parentheses. Now, why is that? Y squared plus 1 is always what sign? Positive, right? It's always positive. Y squared cannot be negative. The smallest it can be is 0. And now if I add 1, it's dead sure positive. So if an expression is always positive, you take off the bars. Okay. So this is the best final answer. ln absolute value of y squared plus 1 plus c. Okay, now how come I didn't do that over here? Well, does the inside have any probability of being negative? Sure, an easy way is plug in 0, right? If you plug in 0, 0 minus 1 is negative. Okay, so you do need the absolute value. So if the inside has a possibility of being negative, keep the bars. That's not true here, right? Y squared plus 1 isn't going to be negative, so you drop the bars. Okay, something similar happens in 26. Okay, 26. Let's see. 4, 3, 2, 1. So the derivative of this is probably close to this. In this particular case, it's exactly equal. Okay, so u equals x to the 4th plus x squared. Du equals 4x cubed plus 2x dx. Perfect. I don't have to multiply by anything. The bottom is my u. The top is du. And by the way, this dx, it's hanging off to the side. You could pretend it's in the numerator. If it's dx, it's like dx over 1. So even though it may be sunken down a little bit, you know, at the same level as this bar, it's in the numerator. So that's my du. It is du over u. Remember, if it helps you, you can always have the option of sneaking in a 1 du over u. Basically, it's 1 over u. So yeah, that's my natural log, right? So natural log absolute value of u plus c. What was u? X to the 4th plus x squared. So ln absolute value of x to the 4th plus x squared plus c. And then last thing, x to the 4th plus x squared. Is there any possibility that that comes out to be a negative? No, right? When you raise something to the 4th power, can't be negative, right? Because even if you plug in a negative to the 4th power, negative times negative times negative times negative is positive. Similarly, x squared is non-negative. Add them up, can't be negative. So once again, drop the bars. Okay. All right, so I think I've given you enough of 12.3. Now I'm going to switch attention to start giving you some of 13.2. Again, the reason for that, so I'm not complete with 12.3, but I think you've given you enough to get started. But I do want you to have at least a week to see how 13.2 works rather than just 2 days if I waited until Tuesday. Okay, so 13.2. So now they have numbers here, 0 and 1. Okay, so 13.2. Something called the fundamental theorem of calculus. So what does that mean? My page 799. Let f be a continuous function on a closed interval from a to b. Then the definite integral of f exists, and the integral from a to b of f of x dx is capital F of b minus capital F of a, where capital F is any function such that capital F prime of x equals f of x for all x in the interval a, b. Okay, it sounds scary, but it's actually much easier than you think. Okay, you anti-differentiate, you integrate, you plug in the top number, you plug in the bottom number, and subtract. Okay, so you can put this on your cheat sheet. I really don't think you have to. Okay, if you just watch what I do, you kind of get the hang of it, then you got it. Okay. What's so good about having this is it gives you area under a curve, believe it or not. It's beyond the scope of our course, but if you were to take a formal calculus course like Math 110A or something like that, or the calculus sequence, they would teach you more about that. But on page 802, what it's good for is giving you area under a curve. Okay, and I'll illustrate that in just a second. Okay. So 13.2, number 2. Okay, 13.2 is our last section. Right. Again, I'm not really finished with 12.3, but I think I've given you enough to get started with it. I'll finish it up on Tuesday, but I want to at least show you some of 13.2 so you get the hang of it. Okay, integral from 0 to 1 of 8x dx. Now, if they don't have the 0 and a 1, you know what to do. 8x squared over 2 plus c. Okay. Now, what happens if you have numbers? Okay, you still integrate. You no longer need the plus c. You don't need the plus c for these integrals. It's called definite integrals. These are called indefinite integrals. Indefinite integrals. These are definite integrals. You don't even need to know that if you don't want to. But definite integrals have definite numbers. Okay. So 8x squared over 2, don't need the plus c. And then what happens is this funny looking s with the 0 and 1. By convention, it moves over to the right side and straightens out. 0, 1. Okay, that's 4x squared from 0 to 1. Okay, now you plug in the upper number, 1. Plug in 1, you get 4. Plug in 0, you get 0. Final answer is 4. Okay, so for these kind of integrals, the final answer is a real number. these integrals, if they don't give me a number here, the so-called indefinite integrals, your answer is going to be blah, blah, blah plus c. The final answer here is a real number. Okay. Now the problem's finished, but digging deeper, what is it giving me? Here's the graph of y equals 8x, right? If I plug in 1, I get 8, 0, 0, 1, 8. What's the area of that triangle? Well, it's 1/2 base times height. 1/2 of 1 times 8 is 4. That's what it gives me. Very powerful too. So this integral is giving me the area under the curve from A to B. Okay. Frankly, you don't really need to know that. It's nice to know, but in terms of actual working things out for test or final exam, just integrate, plug in the top number, plug in the bottom number. Okay, so that's what we're up against now. Okay, number 4. Integral from 1 to 5 of 2y dy. So what's the integral of 2? Well, they tell you the variable is y. So you put 2y. If it said 2 dx, you would put 2x. If it said 2 dt, you would put 2t. So the d names the variable. So it's 2y. Okay. From 1 to 5, plug in 5, 2 times 5, 10. Minus plug in 1, 2 times 1 is 2. So the answer is 8. What does that mean on the picture? For the function f of x is 2, that's a constant function. And if I go from 1 to 5, the area is 8. Is that true? Looks like a rectangle. Y equals 2, so the height is 2. How far is it from 1 to 5? 4. 4 times 2 is 8. It works. Okay, so we can verify that for nice shapes like rectangles and triangles, but it even works for curved objects. The next one's really nice. 0 to 5 x squared dx. What we're actually getting is this. Y equals x squared looks like a parabola, right? Going from 0 to 5, we're finding the actual area under this curve for a curved object. Okay, so here we go. X cubed over 3. Don't need the plus c. Okay, you do need the plus c for these indefinite integrals. See, what's the difference? There's no numbers here. Okay, if there's no numbers to plug in, final answer should have a plus c. If they give you numbers, you plug them in, your final answer is real number. Okay, so plug in 5. 5 cubed is 125. 125 over 3 minus plug in 0. 0 cubed is 0. 0 divided by 3 is 0. So 125 over 3 minus 0. Plug in 5. Plug in 0. Final answer is 125 over 3, which is 40 something, 41 2/3, I think. That is the area under the curve, believe it or not. Okay. All right, do a few more. Number 10. So you can see it's not really that much harder. You still integrate. You do exactly the same thing as all these other ones. You don't need a plus c. Plug in the top number, plug in the bottom number, and subtract. Okay, integral from -1 to 4 of 6x minus 9 dx. Okay, integral of 6x. Remember, x is like x to the 1, right? So 6x squared over 2 minus 9x. Okay, the funny looking s, which is on the left side, migrates over to the right side and it straightens out, -1 to 4. And of course, 6 divided by 2 is 3. So 3x squared minus 9x from -1 to 4. So it's a little bit harder. Okay, plug in 4 in parentheses. Plug in -1 in parentheses. Okay, 4 squared is 16. So I have 3 times 16 minus 9 times 4 is 36. Okay, clean this up. 3 times 16 is 48. 48 minus 36 is 12. Okay, plug in -1. -1 squared is 1. 1 times 3 is 3. Plug in -1 here. -9 times -1 is a +9. 12. 12 minus 12 is 0. Answer is 0. Now, how can you have answer come out to be 0? The problem's finished, but I'll dig deeper. How can you have an area of 0? Okay. This is what the graph happens to be of 6x minus 9. Okay, if I plug in -1, I get -15. If I plug in 4, 6 times 4 is 24, minus 9 is +15. And if I go halfway, 1.5, halfway between these two is 1.5, believe it or not. You don't have to worry about that now, but it's 0. Okay. By symmetry, I get as much area below the x-axis as above the x-axis. So they would cancel out. So technically, you don't get the area under a curve. You get the signed area, where anything above the x-axis is counted as positive. Anything below the x-axis is negative. This area exactly matches this area. So the integral, this would come out to be positive. This would come out to be negative. So the net result is 0. Okay. In short, if your graph is below the x-axis, the integral will come out to be a negative. So here you have just as much area below as above. So that's the reason why it comes out to be 0. Okay. All right. Okay, 14, integral from 2 to 4 of 3 radical x dx. Okay, of course, treat square root of x as x to the 1/2. So here we go. 3 times x to the 3/2 divided by 3/2. But we know dividing by 3/2 is the same as multiplying by 2/3. Cancel the 3's. So I have a 2, right? You're allowed to factor the 2 out. So factor the 2. Notice again the symbolism. Integral, funny looking s, 2 to 4 is on the left. After you integrate, it moves over to the right and straightens out. So plug in 4 to the 3/2 minus 2 to the 3/2. Okay. You might recall when you have a fractional exponent, power is on top, root is on the bottom. So you take the square root of 4. What's the square root of 4? 2. Cube it, 8. Minus. Okay, the best way to do 2 to the 3/2, treat it as 2 to the 1, 2 to the 1/2. Okay, 1 plus 1/2 is 1.5 or 3/2, right? And the reason why you want to write it like that is because what's 2 to the 1? 2. And 2 to the 1/2 means square root. So the cleanest way to write the answer is this: 2 times 8 minus 2 radical 2. Or you can distribute, if you want to distribute 2 times 8 is 16 minus 4 radical 2. That's okay also. Okay. All right, one more like that is 18. Okay, integral from -1 to 0 of x plus 2 to the 13th dx. Okay, so I just do the power root. I don't have to do a u substitution this time. You could, it works. But what's the derivative of the inside? 1, which means I don't really need to do a substitution. Just go x plus 2 to the 14th over 14. Okay, double check. What's the derivative of this? 14 cancels the 14, x plus 2 to the 13th, times by the chain rule, the derivative of the inside. What's the derivative of the inside? 1, so it works. Okay, so I'm going from -1 to 0. Okay, plug in 0, you have 2 to the 14th, which is a super big number. Plug in -1, -1 plus 2 is 1. 1 to the 14th power is still 1. Okay, so you have 2 to the 14th minus 1. Punch it in your calculator, 16,383, over 14. Okay, you take my word for it, or maybe I'll just go ahead and show it to you. 2 to the 14th minus 1. 2 to the 14th minus 1, 16,383. So 16,383 over 14. Okay. All right, let's see. What time is it? I can go a little bit long. I'm done with everything I was going to do, but I might as well sneak in a little bit more, because the more I sneak in now, the less we have to do Tuesday, and you may want to ask questions for the test. So why don't I sneak in a few more before I give you the quiz? Okay. There are some more, do some of the odd ones. Integral from 2 to 4 of x cubed dx. So x to the 4th over 4. Don't need the plus c. 2 to 4. Well, dividing by 4 is the same as multiplying by 1/4. So I factored out the 1/4. Plug in 4, 4 to the 4. Plug in 2, 2 to the 4th. And then you can punch it in your calculator. 1/4. 4 times 4 times 4 times 4 is 256. 2 times 2 times 2 times 2 is 16. Subtract 240. 240 divided by 4, 60. Okay. Then number 9. Integral from 1 to 4, 10 minus 4x dx. Okay, integral of 10, 10x. Integral of negative 4x. You see, I did a shortcut here. It's negative 4x squared over 2, right? And it's, oh, negative 4 divided by 2, negative 2x squared. So if you want to go straight from here to here, I'll let you. Okay, then you go from 1 to 4. Parentheses, plug in 4, parentheses, plug in 1. So plug in 4. 10 times 4 is 40, minus 2 times 16 is 32. Then plug in 1. 10 times 1, 10, minus 2 times 1 is 2. 8 minus 8, 0. So the answer is 0, which again indicates to me most likely this is another situation where you have just as much area above as below. That's my guess. What happens here? Okay, let's do a couple more. 15. Integral from 1 to 3 of 3y to the negative 2 dy. So 3y to the negative 1 over negative 1 from 1 to 3. Clean up the algebra. That's negative 3 times 1 over y, right? Y to negative 1 is 1 over y. Take out the negative 3, 1 over y from 3 to 1. So leave out the negative 3. Plug in 3, you have 1/3. Minus plug in 1, you get 1. Negative 3 times 1/3 minus 1 is negative 2/3. And negative 3 times a negative 2/3 is a positive 2. And that's it. Okay, what time is it? Not quite 5:30. So I'll still leave you with 25 minutes for the quiz, so you should be good. Okay, so I'll stop with 13. Okay, a little bit harder. I want to do this one after that because this was harder. 4 cube root of x squared. Integral from 0 to 5. Okay, how do you write that as a fractional exponent? X to the 2/3. Right, so power root, 4 times x to the 5/3, 2/3 plus 1, right? 2/3 plus 3/3, 5/3 divided by 5/3 means multiplied by 3/5. You're going from 0 to 5. Okay, this comes out to be 12/5. Plug in 5, you have 5 to the 5/3. and minus 0 to anything is 0. So I have 12/5 times 5 to the 5/3, although you can clean that up a little bit. I'll show you how to do that. 12 divided by 5. 5 is like 5 to the 1, right? There is 1 3/3. It's 5 to the 5/3. So 5 to the 5/3 divided by 5 to the 3/3. I'm supposed to subtract. So best final answer is 12 times 5 to the 2/3. And that's it. Okay, I'm finished. If anybody has a question, you can put it in the chat right now. Let me do my focus thing. Okay, so I think I've given you enough of both 12.3 and 13.2 to do the rest of the problems. But if not, I'll go ahead and finish that up on Tuesday, and then next Thursday's the test. Okay, so that's that. Not sure if I remember to do it for this. So let me go back to this. So this is everything from today, okay? Today's quiz will be on substitution though, the use substitution. So your answer should be blah, 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 plus C. Move that over. Try to get both of these at the same time. There's that. I think I showed you most of this. And that. And then this. Okay. And then the back side. Why don't I just go one column at a time? And that. And then that. Okay, we're done, folks. Okay, so again, you should have enough information to do the rest of 12.3 and 13.2. In fact, I'm just going to go ahead and mark off 13.2, although I'm not really complete with either 12.3 or 13.2. But if you understood what we did today, you should be able to finish the rest of the homework, but I'll continue with that on Tuesday. Okay, I'll check the chat. Any other questions, please? Yeah, anybody who joined late, put you down. So Aries, I got you. Dahua, Omar, got it. Jonathan, okay. Any other questions? Otherwise, we'll go straight to the quiz and that'll be it. Okay, so quiz time. Get your cell phones out. I'll be ready to do a screenshot. Okay, find the following integrals or antiderivatives. Do it by use substitution. It's actually fairly straightforward, I think. Number one, integral of x squared plus 1 to the 5th power times 2x dx. Number two, integral of 2x cubed plus 4x squared minus 5x minus 1 to the 8th power times 6x squared plus 8x minus 5 dx. Okay, the substitution should be fairly straightforward. Remember, you're looking for a function and its derivative. Do you see a function and its derivative for problem 1 and problem 2? Hopefully it's pretty straightforward. Okay, so go ahead and get started. I'll keep this up for maybe another 10, 15 seconds and then set up your breakout rooms. And that'll be it for tonight. Okay, so just hold it a little longer. So if you haven't already gotten it, please get it in the next few seconds. Okay, I will now assume everybody has it. So I'll stop the share, get started on it. And get that.